Welcome back to Peanut Workshop. Tonight I am finally going to be working on this Peg Perego Gator. My son got it for his 3rd birthday quite a few weeks ago now, and he broke his leg, so he couldn't really drive it right after his birthday. So his leg's almost healed and I need to get it back together. So far all I have is a linear actuator for the dumping. So I have a switch hooked up. It is a 12 volt. I have it hooked up to 18 volts. So up and down. That is working pretty well. I have designed a bracket down here. So this is a 3D printed bracket that gets bolted in, and then bolt the linear actuator to it. I will get the 3D file and the print file on the website somehow. So if you guys are interested in doing the same thing, you can download that and print one for yourself. And then up at the top, I got bolts in there. So we're bolted in. There's a little bit more play than I would want in it. I had to cut quite a bit of material out of here. So when I was mocking everything up, I didn't have the material cut out, and I ended up cutting out too much. But yeah, it should be good. Definitely with a little more refinement on that 3D printed bracket, it would be a lot better. At 18 volts, that linear actuator runs pretty quick. I'll post the exact size that I used in the description, or the exact speed, size and speed. I'll post the one I bought. See, when it's down, there's a little bit of movement on it, which is that bottom bracket. So a little disappointing. I think I can fix it. Probably won't do it anytime soon. Probably won't do it. We'll see. We'll see when he has it out and running and how it goes. All right, a few other things we're doing. We have white lights. We have red lights for the back, and then we have yellow lights for the front. I have white illuminated switches. Well, I have illuminated switches, white, red, yellow. I have the latest from Peanut Workshop. When I install these in my kids' toys, I use rejected, like, enclosures that failed quality control. So got a mix, got a nice white and black. I have a throttle pedal, I got a green pedal adapter, and then we're going dual parallel rigid batteries in this build. Only extra materials I really expect to need is just the hole saw for installing these lights. These are just little LED trailer lights that are meant for like the side lights, and then just standard. I think I bought 18 gauge wire. These are very low power. I plan to power those all off of the 12 volt output. We'll see if that is too much of a load or not. I don't think it will be. Calculation wise, it'll be fine. We'll see. I have this mostly torn apart, so I should be ready to start drilling holes, installing lights, and wiring it up. I will try to document anything that I think is particularly difficult or confusing, but I think everything here is going to be straightforward. I'm just going to pop these covers off and drill the holes and hope that that hole size is the right size. I haven't tried it in plastic, so yeah, they just press in. I tried it in some cardboard and it was the right size. Yeah, I tried a few different hole sizes, and that was the size that fit the best. So we're gonna give it a shot. Maybe I'll try it in a piece of scrap plastic first. First light is in, and that is flush and looks pretty good. Not sure if maybe I can get a better light. Well, it looks good. We'll get the other ones in and then get them wired up. See how they look turned on. I have all of the lights in that I wanted to get in. So these 4 fronts, and then the 2 in the rear. So next I'm going to finish disassembling this. I got to get the original battery out of the front still. I don't think I mentioned this at the beginning, I'm going to leave the factory motors running 18 volts until they burn out. Once they burn out, I'm going to figure out what I'm going to do next. I think I'm going to try and come up with a way to fit our 887 motors in here. I have tried to make an adapter to go from 550 to 887, and the center to center spacing on the mounting holes are just so big that I couldn't make a spacer. It wasn't going to work, at least not a 3D printed one. Need to get the throttle pedal out, need to get the battery out, expose the rest of the wiring, get rid of the factory thermal fuse, assuming that's what's in here, and install my own fuses. So every battery I run a fuse that's appropriately sized for that battery. I recommend you do the same. Have the factory battery out. The factory battery's up here. There is one screw. I really find that annoying that there's a screw to access the battery to charge this. I do not understand why they would do that. Because of that, what I'm going to do, I'm going to put the controller up here. I think I'm going to put the batteries here and here. I think that'll be out of the way. I'm going to put the switch here. I think here, the actuator switch, and then I think the 3 push buttons, I'm just going to line up with the fake buttons on the switch there for the lights. I think that'll be good. Before installing the pedal in the Peg Perego, pull the plate out. I'm going to take the Dremel and I'm just going to go around this here. This should bolt right on top. Well, screw right on top. It should be a real easy install. That the molded plastic that fit the pedal, that's gone. This is going to fit pretty nicely. I'll be able to position this where I need it to route the cable through there. This will work well. There it is. Pedal is mounted to the factory plate. That should snap right back in. Doesn't bind. And it is a really close clearance here for the pedal coming through and the wire, but it did fit. These last 2 screws on the side, those are a little on the, those are right on the edge. One missed, one didn't. Yeah, we'll see how that goes. I think it'll be fine. I think we'll still be able to fit it. I'll probably have to pull these screws out and put them back in once this plate is in the car. When I hook up these cars, I run 10 gauge wire. This is 10 gauge. It's not normal silicone wire insulation, but I run 10 gauge from the battery. I'm gonna probably run 2, one per battery, and then I'll run the 2 motor wires to the back, and I'm gonna run the motor wires back to the front to detect direction, and then I already have the original power input, and I'm gonna run that to 12. I can tap off the 12 for the lights, and this should work pretty well. So, I don't have a spool of the normal wire I use. I just had some of this laying around. So it's probably going to be enough to wire this up. Peg Perego did use some very good wire. This is 12 gauge copper stranded wire. I would say this is as good as Power Wheels. Power Wheels, no, I don't think Power Wheels runs 12 gauge. I think they run 14 gauge. But I think this is the best wire I've ever seen in a ride-on. So you really don't need to worry about the main wiring harness for stock motors. Shouldn't need to. Quick overview on the speed controller itself and how we're going to be wiring this thing up. So motor A, that's going to be one of the motors. Motor B, that's going to be the other motor. This thing can do pretty easily about 40 amps per channel, 80 amps total. You can run dual motors. You can wire 2 motors into each of these outputs. 775s or 887s, it's not a problem. Definitely 550s.
40 volts max voltage, and then you have 2 plus, 2 minus. These are 6 gauge terminal blocks. Each of these connections is rated for 65 amps. Continuous, that is 65 amps continuous. And when I say 40 amps per channel, that's 40 amps, 100% at 50 degrees Celsius. This isn't ratings like you find in remote control car ESCs, which will say 100 amps, but that's 25 degrees Celsius ambient temperature with an on time of like 1 minute, off for a couple minutes, on for 1 minute. This is 100% on, 40 amps. I rate things appropriately. V in plus to on, just gonna leave that jumpered. Plus 12 volts, that's gonna go to the original 12 volt input, battery negative. That's the original negative input from the battery. Then we have left plus, left minus, right plus, right minus. That indicates the 4 motors. The wires connected to the 4 motor wires that are currently connected to the motors. I'm gonna disconnect those and connect those here. So keeping the left motor and right motor straight, keeping those wire pairs together, and they're gonna come in here and get wired in. And those are coming out of the direction selector. So the 12 volts is gonna go into the direction switch, the same as it does in stock car. And then it's going to feed these, which way the voltage is going for left and right motor, whether it's parallel, series, forward or reverse. And that's gonna select forward high, forward low, and reverse, the same as a stock car. 5 volts, don't need that. And then the T, that's the throttle input. The throttle has 3 wires, green, black, and red. Green goes to T for throttle, red goes to 3.3 volts for power, and the black goes to B negative. And that's everything that needs to get wired on. So we have A, negative plus B, plus 12, battery negative, 4 motor wires, and then the 3 throttle wires. And that'll be it. Important thing to note, if you are not using the original motor connections or have a car that doesn't work for, like if you have one of the Chinese cars that have like a wheelie controller in it, something like that, there are these 3 inputs over here: forward high, forward low, and reverse, FH, FL, and R. And you connect these to battery negative, not 3.3 volts, not 12 volts, the battery negative, any battery negative terminal. You can do this one next to the throttle and brake. You can use this one next to 5 volts, this one next to 12 volts, or you can use the main one up here. Doesn't matter, but it does have to connect to battery negative, and you have to select a direction in order for the controller to work. It doesn't just default to forward or reverse. You have to tell it if you want forward or reverse. Quick status here, what I have done. I have wired the throttle, black to B negative, red to 3.3, green to T, and then I have the 4 motor wires extended out and run in. I'm gonna leave these screwed in. These are going to some lever nuts. We're gonna if we have to make changes to get the direction correct, then we're gonna move those. I do have the original 12 volts and battery negative connected to 12 and B negative, and then I have the jumper for on, and then I do have 1 wire run, partially run for a battery. All right, connect battery connections. I typically use these Wago connectors. These are the 10 to 20 gauge version. I forget the exact part number. They're 221s, but then there's another 3 digits after it to represent the actual size. Here's an important step that a lot of people, including myself, forget. The power for detecting direction is still going through the old plunger switch, so you do have to connect that. You can leave the plunger switch in and press it and tape it pressed if you want. What I do is I cut the red and this white. So the center pin, battery positive to the center pin. That's where you have to short, and this little blue wire, that would be the brake. So we don't need that anymore. We have electronic braking. So we're gonna cut the red and white and short those together with we'll just connect it with a Wago lever nut. I have everything for the speed controller hooked up. So I got motor spinning opposite direction, so I'm gonna have to fix that. Have to log into the app, figure out what direction it thinks we're going. I am logged in. Remember, you go to the network connection, speed control, password speed control by default. If you're intending to use this near anyone else, make sure you change your password so people can't log in and make changes. And you can change your network name to whatever you want. I'm gonna do that now. I'm gonna call this Gator. And submit, you have to click submit before any change you make in here to take effect. All right, then we're gonna go to diagnostics and check to see what our direction says. All right, diagnostics says I'm in forward low. I already checked and I'm not getting reversed. So that means I need to make some changes. Let me figure out what I need to change real quick. Well, let me show you what needs to change. So the 4 left plus, left minus, right plus, right minus, those aren't in the right configuration to detect reverse. So I'm not gonna unscrew those terminals and mess with those. I'm gonna change these terminals here so that I can get reverse. What likely has to happen is I'm gonna have to switch left and right. So I'm gonna switch these two with these two. Don't mix up your motors. So always keep the red and blue together and the black and white for this car. All right, let me figure that out and I'll come back. All right, that's all I did. I switched the left and right motor pairs, and now I get forward high, forward low, and reverse as needed. So now that I know it knows it's in forward high, let me see which direction the motors are spinning and figure out which motor has to change the polarity. That wheel's spinning forward, that one's right. This one's spinning reverse, so I have to switch the polarity on this motor. So back here at the motor, I'm gonna pop these off and switch them around. Both are moving forward. Let's hold this gear selector in reverse. Both are in reverse, low. And both are forward. So that's good. I am done with the motor controller installation at this point. Now I need to change my low voltage threshold since I'm using drill batteries. So I'm going to go in here and I'm going to change. I'm going to keep frequency at 10 kilohertz, leave brake frequency at 1000 hertz. Low voltage threshold for this, I'm going to go 16.7. Submit. All right, I'm gonna leave the ramp up, ramp down, default settings. I think those will be good, we'll see. With a variable pedal, you can do pretty low. Yeah, everything else, I should do my current limiting, default's 45 amps. Let's just go with 25 amps since this is stock. Let's see how that goes. I'm not really sure. I rarely ever run stock motors. All right, done with this. Now I need to wire up the actuator to 18 volts and I gotta wire up all of the lights to 12 volts. Here is the switch I'm using for the actuator. It has nice up down arrows and I have a plate this goes with. Came with this nice aluminum plate so I can mark where the switch goes. Cut that out with the Dremel tool. Press the switch into the plate, screw the plate in, and it should look nice and premium. Finished wiring up the actuator. Got that going. Down. And up. Next is lights. I finished wiring up the lights today on the Gator. So I have the headlights, daytime running lights, and the reverse light, well, tail lights. Those are on. I got the electric actuator wired up. So it goes up and down. I have all my wiring pretty nicely tidied up. I got 3 push buttons, white lights, yellow lights, and the tail lights. Oh, those are all wired up. The kids rode it for quite a few hours today, no issues. As I was recording to show putting the bed all the way down, I saw that it was binding here, so I had to clearance this plate just a little bit. I just installed this plate. I left it out all day. The motors are under there and some wiring. I wanted to put this back on. So as I was doing that, I saw the lift bed was, the actuator was hitting there when it was all the way down, preventing it from going all the way down. So that should be good now. All right, got the actuator put back in, back connected. There is some movement here in the bed when it's down, but it's not that bad. They really were hauling wood and leaves around all day today, and it was fine. So everything's buttoned up. Overview what we have going on. We have 3 push buttons for the 3 sets of lights, tail lights, the front running lights, and the white headlights. They seem pretty bright. They haven't run it at night yet, but as it gets to fall and winter here, they usually ride these all winter long, and it gets dark at 5 o'clock, so they need headlights. Now, we have variable speed. We have the Speedy Squirrel speed controller. That's currently set to 100% for high, 75% for low, and 75% for reverse. Remember, that limits the PWM output to 75%. That's all that number means, so it's really a power limit, not necessarily a speed limit. It does limit your power, which limits your speed, but you know, it doesn't have any feedback. It's got dual rigid batteries, 1 on each side. These are wired in parallel, so we are running 18 volts on this. I'm running 18 volts straight to that 12 volt linear actuator. Probably should have bought a higher speed, lower power one, because the bed does move pretty slow. So if I were to do it again, I would go with a higher speed actuator and slightly less powerful. It was powerful enough to dump my 5-year-old out of the back of it, so it did work well. Currently we're running stock motors. We didn't upgrade the motors. We'll run those until they die. Once they die, we're gonna bump those up to Andy Mark 775s probably. We'll see if we can fit the 887s in. I know we can make those 775s fit, so I expect the stock motors to last a while, so it'll probably be a while before we do any more upgrades to this. This is a good speed stock motors, 18 volts, is 7 to 8 miles per hour. That's good enough for the Gator. We have plenty of other fast vehicles for them to drive if they want to go fast. So here it is. I hope you enjoy this build, and like and subscribe to our YouTube channel, follow us on Facebook, and check out the website if you're interested in the speed controller. I am going to get this actuator bracket that I designed listed. It's not going to be for sale. You're not going to be able to buy it from me, but I will have the file available so people can download that and print it for themselves. I print it. Anything I do that's not needing high temperature material, I print out a PET G. It's a UV resistant outdoor material, so this should, and it's also very sturdy. So I printed a very strong version of it. I think it's like six solid layers before it starts to do infill, and the infill is like 25%. So it's a very sturdy bracket. This isn't going to break. So yeah, here it is. I had to drill, oh yeah, a couple more things. I had to drill holes here to fit the fuses through. So I do have access to the fuses on the bottom. Tried to tidy up the wire as best as I'm capable of, at least. Running 4 pairs of 10 gauge wire through the original holes wasn't going to work up to the speed controller here in the front. So yeah, I drilled some holes here and ran those. And then I did get the wiring neat enough here for the pedal. You know, you can see a few more bundles coming through, but not bad. The pedal's in good. It's sturdy. The switches up here, there was the black plastic, and then underneath it was the same molded shape for the green plastic. So I basically had to cut all that green plastic out to fit these switches in there and the wire harness for the switches. But those are very nice. Look in the description. I'm gonna put all the materials that we use for this build in the description. So, all right. Hope you enjoyed the video.